In this video, I am going to walk through how to subtract rational expressions. Whenever you are adding or subtracting rational expressions, just as you would do when you're adding or subtracting simple fractions, you must find a common denominator before you can combine the two pieces. So in this example, we look at what we have in both denominators, and we have an x minus 2 under the first rational expression, and we have an x in the denominator of the second rational expression, shown here and here. So to get the least common denominator, you're going to need to come up with the least common multiple of these two factors, x minus 2 and x. So in this case, it actually just happens to be the product of these two denominators. So x times x minus 2. So if we want both denominators to show x times x minus 2, we need to figure out what we're missing in each rational expression in order to get this denominator. Okay? So in the first rational expression, I have the x minus 2, but I'm missing the factor of x. Since I'm missing the factor of x, I multiply both top and bottom of the first rational expression by x. So here you'll see the original 9 over x minus 2, and then you see times x over x. This is new. This is what I'm going to multiply my first rational expression by in order to get a denominator that shows x times x minus 2. So in the next line down here, I'm going to put an arrow. Now you'll see I took the 9 times x, and that gives me the 9x in the numerator. And in the denominator, I'm going to take these two factors times each other, which gives me the x times x minus 2, which is what we want. I'm going to erase a few little things here. I think it's getting a little messy. Okay, so that was just the first piece. The second piece, I'm going to do the exact same thing. I started with just an x, but remember, I want to get x times x minus 2. So I need to multiply top and bottom of the second rational expression by x minus 2 over x minus 2. So you'll see this was the original, 3 minus 3x over x, and now I've multiplied it by what was missing to get my least common multiple, the common denominator, x minus 2 over x minus 2. So if I multiply this numerator times this numerator, you'll see that that's how I get to the next line down right here. 3 minus 3x, which is what we started with, and this x minus 2 is from right here when I multiplied top and bottom by that x minus 2. And then of course on the bottom, you'll see I had an x to begin with, and we're going to multiply it by the x minus 2. So this line here, I hope it makes sense. My goal was to get the denominators to both be that least common multiple x times x minus 2. In order to get that under both denominators, I knew I had to multiply each rational expression by the missing piece. Okay? So in the first one, the missing piece was x, so I multiplied top and bottom by x. In the second rational expression, the missing piece was x minus 2, so we multiplied both top and bottom by x minus 2. So that gets us here to this second line. Now that we have the common denominator, we can start simplifying our numerators, like how I have all these, how I have these parentheses up here, right? We know we can FOIL that out and simplify that. So I can simplify my numerators a bit and then just go ahead and do the subtraction. So the next line shows that I'm using FOIL to multiply these two binomials right here. So FOIL says first terms, outer terms, inner terms, last terms. That's FOIL. So when I multiply first terms, I'm taking 3 times x, which is how we get 3x squared. Or sorry, 3 times x, which is how we get 3x. And then, so there's 3 times x is 3x. 3 times negative 2 is negative 6. Here's my 3x squared. I take negative 3 times x, my inner terms, and I get the negative 3x squared. And I take negative 3x times negative 2, and I get positive 6x. So this is how we get that numerator there. And notice my denominators don't change, and I didn't need to do anything to simplify the 9x. My next step will be to combine any like terms in that second numerator. So I notice I have a 3x and a 6x. So these are like terms. And so that gets me to our next line down. I have 9x over x times x minus 2 minus, this was minus this whole time, right? So I'm just carrying that minus along, minus, and then I just combined the 3x and the 6x to give me this 9x here, and I reordered it. It didn't change anything, but I reordered it so that I would have it in descending order, and I would have my highest exponent listed first, and that's how we get that negative 3x squared. It just came from up here. I just moved the order, plus 9x, which I got from the 3x and the 6x, and then minus 6 will tag along there. So I've done everything I can to simplify this second rational expression, and now we're ready to just subtract the 2. So remember, that subtraction there means it applies to every single term in this second numerator. So I have 9x minus, and then that's why we have parentheses to show that that minus applies to every single term inside. And so when I distribute that minus sign to every single term, what it does is it changes or flips all of my signs. So when I've distributed that negative sign, that negative 3x squared inside, I have a negative of a negative 3x squared, which is the positive 3x squared. And likewise, the positive 9x now becomes negative 9x, and the negative 6 becomes positive 6. So in essence, it just flipped all of the signs on the inside. And so now I have 9x plus 3x squared minus 9x plus 6. Combining like terms, I see I have a positive 9x and a negative 9x. So those completely cancel each other out. And I'm left with 3x squared plus 6 over that common denominator of x times x minus 2. And then one last step for me would be looking at this numerator. I see that I have a common factor of 3 between these two terms. So I simply factor that 3 to the outside. And what's left on the inside when I factor the 3 out is x squared plus 2 on the top. So I have 3 times the quantity of x squared plus 2 divided by x times x minus 2. And this is as far as we can go. This isn't wrong to leave it like this, but whenever you see a common factor with rational expressions, it's really smart to factor that out, because there may have been, or you may see a problem where maybe there's a 3 in the denominator, right? And then when we factor that 3 out of the numerator, maybe there's a factor of 3 down below, and those would cancel each other out. In this case, it's not, but that's just a good habit to get into. So I hope this little explanation of subtracting rational expressions has been helpful for you.